All right, question number 4. For each function, state the amplitude, then the period in degrees and radians. All right, so if I have y is equal to a, and this can be sine bx, or y is equal to a sine, a cos bx. We know that a is our amplitude and b affects our period because a is your vertical stretch and b is your horizontal stretch. But they're not asking for those, so we're just going to deal with amplitude and period. So here, my amplitude is equal to 3. My period in degrees is calculated by going 360 degrees divided by b, which in this case is 360 divided by 1/5, which is 1800 degrees. Because it's a horizontal stretch by a factor of 5, and that's why that gets so much larger. Now, in radians, it is 2 pi divided by b, which is 2 pi divided by 1/5, which is 10 pi. All right, for part B, again, amplitude is pretty straightforward. We're just going to deal with it being 2/3. Period is equal to 360 divided by b, which is 2/3, which is 360 times the reciprocal of this, which gives us 540 degrees. And then my period in radians is 2 pi divided by 2/3, which is 2 pi times 3/2, which, if my math is correct, gives me 3 pi. All right, and lastly, here my amplitude is 1/4, because we don't talk about amplitude being negative. And again, we don't talk about the period being negative either, because it's the measure on the x-axis for how long it takes to go through one cycle. So my period is 360 divided by 3, which is 120 degrees. And in radians, 2 pi divided by 3, so we can just leave it there. It's already simplified. All right, let's take a look at these graphs. And just for the ease of it, we are going to focus on this actually being the graph of a sine function. Now, I need you to think about something. When I am graphing sine x before there's been any transformations, in degrees, this graph has a period of 360 degrees. It has an amplitude of 1, so that puts its max and min at 1 and -1. We did this in radians a little earlier in this lesson, so we know it crosses here at 180, and it hits its max at 90, and its min at 270. Now I'm going to transform that function. So what's going to happen is we're going to have a vertical stretch by a factor of 2 and a horizontal stretch by a factor of 1/4. So if I take my key points here, they're at 0, 0, 90, and 1, 180, and 0, 270, and -1, and 360, and 0. So these are from the graph of just y is equal to sine of x. Well, let's see what's going to happen here. I know the amplitude is now going to be 2 because of the 2 in front here. So that translates to every y value being multiplied by 2y. Then I know that this is a horizontal stretch by a factor of 4, or sorry, 1 over 4. So every x value is going to be multiplied by 1 over 4. So let's get a new set of transform points here. I'll do those in red. So that'll be 0, 0, invariant point. 90 times a quarter is what? 45, 22.5. And 2, 180 and 0 would be 45 and 0. 270 divided by 4. What's that? 135. I'll come back to that one. And 360 divided by 4 is 90, and my amplitude, whoops, is 0 here. And back here we have an amplitude, or sorry, a y value of -2. A second here, I'm going to grab my calculator. Go 270 divided by 4, 67.5. All right, let's plot this new graph. 0, 0. 22.5 and 2. 45 and 0. 67.5 and -2. And 90 and 0. So what I do is I draw one cycle of this graph, and then we keep repeating it. So I think the easiest way to keep repeating it, just drawing out the maxes and the mins as they occur. And then the x-intercepts, and then we can connect all the values. Making sure you make these graphs rounded, because your university professors are going to expect that. And I'm just going to back up. And again, I know my min happens. The next one is here. The next max is here. And I'm going to draw them out. And I'm going to connect the points. So it is an expectation that you're able to graph these without using your graphing calculator, because it shows your knowledge of transformations. Is it wrong for you to graph it on your calculator and check it out? No. All right, I'm going to let you have an opportunity to try number 6. Then I'm going to go through it with you, and then I'm going to assign you some homework. Be back shortly.